So I feel like we need just a little bit more practice with domain and range. The main purpose for the calculator activity was to kind of introduce it to us in a sense where we're looking at functions as opposed to just number lines. So I feel like it was a good activity, number one, to get us practice with the calculators themselves, but number two, to get us to see functions and kind of introduce us. So I will relate today's lesson to the calculators as much as I can. If you look here, we're going to do a couple examples together. So you can pause the video, jot down these graphs. I would recommend using graph paper just so your notebook looks a little bit nicer, but it's really ultimately up to you. If we look at this, for number one, I can see that I have a function that's graphed. It starts over here at this closed circle and then goes down in the negative direction, right, for the y values at least. So if I look at this, the domain is strictly the x values. Any x value that is on this line right here is going to be part of my domain. So if I look at this x value, which is 5, is part of my domain. So what I'm going to do, and to, again, relate it to what we did in class, I'm going to draw my domain in blue. So I'm going to start right here where this point is at. And I'm going to say, well, my line goes all the way towards the left, and it keeps going towards the left to infinity, right? So I'm going to draw my line, we can make it a little bit thicker, all the way to infinity. So my domain, really, it doesn't have a smallest number because it goes to negative infinity. So really my domain is anything that is less than or equal to this 5. And again, we said domain was all of my x values. So any x value that is less than or equal to 5 would be part of my domain. If I'm looking at my y values, I'm going to use red again just to relate it to the calculator. So if I'm looking at my range, it's any value, again, that's on this function, and I'm looking at y values specifically. So if I look at this, there's no lowest y value because this arrow tells me that it's going to keep going down in the negative direction. But if I follow my function, there is a highest most point that I can get, and that is at y equals 2. So with that being said, I know that my range is going to start at positive 2, and go down in the negative direction infinitely. So if I'm looking at my range, I know that it's anything that's less than or equal to 2 because this is a closed circle. So y in this case is less than or equal to 2, any of the values that are less than or equal to 2. So that would mean my domain and my range. If I'm looking to see if this is a function, we had kind of mentioned this in the notes before, so I can see that there is no input that has 2 outputs anywhere. So again, with the vertical line test, actually, forget that. We're not going to talk about that right now. I'm going to rewind to that a little bit later. So for now, we'll just focus on domain and range. So domain, anything less than or equal to 5. Range, anything less than or equal to 2. If I look at my next function, number 2, I can see that this one isn't going to go in infinity in any direction, x or y. So I can start with my domain again. So if I'm looking at my domain, I can see that there is my smallest most x value is over here at this negative 5, and it's an open circle. So I'm going to go ahead and draw an open circle right here at negative 5. And from there, I'm going to say, well, if I'm following all along my entire function, the furthest right that I go is here at this negative 2, which means that at the negative 2, again, I'm going to draw an open circle because the open circle correlates to whatever is on my function. So I can see that this value is actually not included on my function. So really my domain is only this small area here because this is where my function passes through. So if I'm looking at this, the smallest value, we always list the smallest value first, so it's negative 5. And that's going to be less than, not equal to, because it's an open circle. So we've got my x values. And the largest most value that I have on this function is this negative 2. And x is going to be anything less than that. So any of these values between negative 5 and negative 2 are possible on the domain of the function that is graphed. So similarly, if I'm looking at the range, I'm going to start with the lowest most point because that's the smallest most number that I can refer to. So looking at this graph, the smallest number I can refer to is this -4. So I'm going to draw an open circle there. If I follow my function all the way up, notice that there are no gaps or anything. This is a continuous function, and it stops right here at this +4. So I'm going to draw another open circle there. And since there's a line of the function that goes anywhere between these values, I know that my range it's continuous again, between -4 and +4. So in this case, I can say -4 is my smallest most value. It's going to be less than, because of that open circle, we're referring to y values here. And then that is less than the +4 that I listed up at the top. Easy enough so far. Now if I look at the third one, I'm going to say, okay, well, again with the domain, I need to find my smallest most value. And I can see that the smallest most value on this function is anything to the left, which is this -4. So again, with the open circle, I'm going to draw an open circle at the -4 on my x-axis. Then I can go on to see how far to the right does this function go. So if I follow along the function, I can see it keeps on going on and on and on forever, which means that when I'm drawing my domain, it starts here at the -4 and it keeps going on infinitely towards the positive infinity, more specifically. So what I can do from here is I can start to list it out. So -4, again, my smallest most value, it is not included because we can see the open circle. So -4 less than x, and I don't have to put an infinity there, because as long as I pick any number that is greater than -4, it will satisfy this inequality. If I'm looking at the range, I can start again with the smallest most number, so I'm going to start in the most negative area, which in this case correlates to this -1. Again with the open circle because I'm always referring to my function. And then I can graph the area in which the range is on my function. So I can see that it starts down here, but it keeps going up and up and up and up forever. So really this is going to keep going up and up and up forever. So with that being said, I can go ahead and go back, write my range as anything that is larger than this -1. So -1 less than y. Simple enough there. What I'm going to do with the next set of examples, same thing, identify the domain and range, but I'm going to go ahead and do it in interval notation. So you'll notice all of these up here are written in inequality form. The next set of examples I'm going to go ahead and do in interval notation so we can get used to that notation as well. So if we're looking at this, again with the domain, I always look at my smallest most value first. So notice this function starts here and then it goes over here, and granted this is not a function but it's a relation. So the relation starts here, it goes up and then over all the way to -infinity. So I know it's going to keep going in that negative direction, which means that in my domain, -infinity is my starting point, really. That's the smallest most number that I can get to. Now, if I follow my function, I want to see the largest most number that I can get to so that I can list that in my interval. So if I go this way, some people want to stop here because they say, well, this is where the function stops. But this is not the largest x value in my function. I really care about the largest x value. So if I go to the right, the largest x value is really here at this 3. So 3, and notice my line passes through the 3, which means that 3 is included in my domain. So if I were to draw the line out, again, the blue line, just like we had with the calculators, it would start here at the 3 because my function passes through that, but it would go in the -infinity direction forever, right? If I'm looking at my range, I can start by drawing it if that's a little bit easier. So again, the lowest, smallest y value is down here at this -2, and it's a closed circle. So I'm going to go ahead and draw a closed circle on my y-axis and say, well, if I follow my function, how high up does it go? So I follow, and notice that there's a little bit of an angle, which means that it's not only going to the left, but it's going up and to the left. So really, this is going to keep going up infinitely as well. So if I'm writing the range for this, again, the smallest number goes on the left, which means that this -2 is going to go on the left. It is included because of the closed circle, which means that I'm going to use a bracket, like we had discussed in class. And then it goes up towards positive infinity. Since positive infinity is not really a number that I can reach or attain, I'll just end my interval notation with that parenthesis rather than a bracket. A bracket is something where you're actually stopping definitively. So this would be the interval notation of the domain and the range for this graph in particular. If I'm looking at this one, again, I'm going to start with the blue. We'll start with the domain. So the domain, smallest x value possible. So if I'm looking at this function here, my smallest x value is over here to the left, and it's an open circle. Now, if I keep following my function, you notice that it starts going to the right. It keeps going to the right all the way over here to this 3. So the 3 is the largest point, and it is a closed circle. So really, my domain is within these 2 points, which means I can write the interval from -4 all the way to 3. The -4 is not included, so I'll put a parenthesis, but the 3 is included, so I can put a bracket. So interval notation for the domain. Now if I move on to the range, I look for the smallest, most y value that is on this function, which is all the way down here at this -5. Open circle because of the open circle on my graph. And then I can say, what is my largest most value? Well, largest most value is up here at the 2. Technically, it looks like this is included, and I understand that on the calculators it said that it was included. Technically, if we're talking about any graph that has a point like this one, that value is actually not included in the function. It's not part of the function, and so we'll discuss that more in the future. But for now, just know anything that's pointed is not included. This previous example was arched. It was not a straight point, so this value was included. But any straight point like this will not be included in my function. So really, my range goes from the -5 all the way up here to the 2. As we discussed just a second ago, neither of these points is included, which means that I'm going to use parentheses on both ends. So -5 and then +2. So that's it for that domain and range of that function. If we go on to number 6, again, same exact thing. So I'm going to start with the blue, start with the domain. Furthest, smallest, most x value is this -4. So closed circle because it's closed on my function. And if I follow along on my function, it keeps going on forever, infinitely, up and to the right. So I can see it's going to keep going to the right. So if I write out the domain for that, smallest value is -4. It is included, so I'm going to use a bracket. And it will go on to positive infinity, which means that I will put an infinity and a parenthesis because we cannot actually attain that infinity. For the range, we can start at the smallest most value for y, which ends up being this point as well, and that is at y = 0. Again with the closed circle because it was closed on my function originally. And we said that this function goes up and to the right. But seeing as how it goes up infinitely, that means this is going to be an arrow that goes up infinitely. So my y values, any possible y values, start at 0. They are included, which means that I use a bracket. And they go up to infinity, and it's a positive infinity. So I can close off my bracket like so, or my interval like so. Hopefully this helps us a little bit more. I feel like some people were confused with the calculators, but this might make it a little bit easier. Let me see here. Bear with me just a minute, guys. So I want to go over two problems that were on the worksheet that some of you may have not gotten to, but I feel like they were very important. So in this scenario, it gives us a domain and it gives us a range, and it tells us to list the endpoints of the line segment and then indicate which endpoint is open. So if I have something like this, similar to a graph, so I know that I've got some kind of graph, and we can just sketch it just for purposes of the understanding. So I've got a graph here. I know that my domain is at -5, which is somewhere over here, and then 3, which is somewhere over here. This bracket tells me that the -5 is included, so if I want to use the same consistent things, it's going to be a closed circle at -5, and then it goes to 3 with an open circle because of that parenthesis. So I'm going to put an open circle there. I know my domain goes somewhere through there. I don't have a graph of a line yet, but I know that when I graph the line, it will go through that domain. If I'm looking at the range, exactly the same way, so I know that the range starts over here at -2, and then it goes all the way up to 4. If I look at the values, this is an open parenthesis, which means that this is an open circle. This is a bracket, which means that the 4 will have a closed circle. And we can draw my range from there. So now if I'm trying to draw the actual graph that corresponds to this of the line segment, I notice that it wouldn't make sense for me to put a point here. The reason being is I have a closed circle above it, and then I have an open circle over here. There's no way that a point could be both open and closed. So with that being said, I'm going to go to an intersection where there are 2 closed circles, which tells me that I can put a closed circle here. And if I look at my x and my y value, really what this coordinate is it's -5. Oh my gosh, sorry. It's at -5, 4. Now, if I do the same thing with these y values, or I'm sorry, not y values, open circles, sorry, it's been a long day. I can put an open circle here where these kind of intersect. And looking at these values here, I know that this coordinate corresponds to -3, -2. So if you ever get a problem like this, I know that I can determine the points based on the domain and the range. So keep in mind that both of these correspond to x values. Both of these correspond to y values. And I think that was probably the most confusing thing about this question. So if we understand that, my 2 solutions to this are this point here, which is my closed circle, and then this point here, which is my open circle. So end of question. Pretty simple once we're able to understand what it is that they're asking us for. Another question that I found interesting was, it said to sketch a graph that satisfies the following conditions. And this one, it gave us a domain of -infinity to +infinity. Again, the parentheses because we can't actually get to infinity, right? The range, it goes from 2 to +infinity. So some people were saying, I don't really understand how to graph that. How do I have, I don't understand. So we can sketch it by saying, well, we've got a graph. I know that my domain is going to be any value of x in any direction. It's basically all real numbers. So I'm going to go ahead and illustrate that in blue. And then for my range, it's anything that's greater than or equal to 2. So really, if this is my 2, I'll rewrite that, sorry. If that's my 2, it's really any value that's greater than 2. So with that being said, I need to think of some kind of graph that would go through any part of the domain, any x value, but only go higher than a 2. So with that being said, I can't draw a line. If I drew a line, it would have to be something like this, but that doesn't go up at all. It just goes from side to side. So I don't want to use that one. I could try to draw a line this way, but really it goes up and down, but I can't go any lower than 2 based on what the range says. So what could I draw? Well, I want you to think about it if you want to pause the video for a bit. Really, what you can end up drawing that satisfies this is as simple as just a parabola. So we can draw a parabola whose vertex starts here at 2, and it goes up in this direction and up in that direction, right? So up and to the right, up and to the left, and that satisfies this. So if we were trying to think of an equation that satisfies this, it would be as simple as x squared plus 2, right? Something simple like that. So I wanted to go over those. That's it for this video. We will practice more of this stuff on Monday, so be sure to have the notes ready for that. And then you'll have another video to watch later on this weekend that will pertain to the things that we do on Tuesday. So this is for Monday's work, Monday, August 31st. So be sure to have your notes ready, and then I will check those in class. Have a good weekend, guys. Thanks. Bye.